Hello, good afternoon, everyone. My name is Aklesh Teli with student ID 20241902223, Integrated Master and PhD under SL Lab. Today I am going to present on RFIC module design, MMIC amplifier. Now, in this presentation, we will talk about the introduction of MMIC amplifier and its important aspect for designing MMIC amplifier. Then we will go through DC bias injection, and then we will also talk about classical stability and the gain analysis. In this we will also consider the noise consideration, then talk practical MMIC amplifier design. We will also go brief on eye of amplifier design and talk about the low noise amplifier design and power amplifier design. Before going deep into the MMIC amplifier, let's go through the introduction of MMIC amplifier. MMIC amplifier are used to boost the power of microwave signal. Important aspect of MMIC amplifier are stability, power gain, bandwidth, noise, and DC requirement. Generally designed using panel technology, where the circuit components such as transistor, capacitor, and resistor are fabricated on a single semiconductor substrate. Its application we can use in the satellite communication and wireless network. On the left side we will see the schematic diagram of the MMIC amplifier. Now we will talk some of the important aspects for designing MMIC amplifier. Important aspect for designing MMIC amplifier, DC bias injection is one of the most important. DC bias is applied to set the operating point on its current voltage characteristic about which the AC microwave signal swings, and the gate and the drain DC bias voltage can be applied to the FET in a number of methods. The drain voltage is required to be positive and the gate voltage is required to be negative. High value resistors are required to apply the bias voltage with the expectation of the low noise and the high power amplifier. The short circuit end is grounded with the decoupling capacitor so that the DC bias can be applied. Self-biasing technique is used, enabling the FET to be biased from a single power supply rail. On the left side we can see the DC bias network diagram. And another important aspect for designing MMIC is classical stability and the gain analysis. The stability of amplifier is very important consideration in the designing and decided based on the S parameter of the active device as well as matching the termination. Stability consists of the two conditions denoted as unconditional stability and the conditional stability. In unconditional stability, the total circuit does not oscillate when any matching network or termination is added, whereas in conditional stability, the total circuit either can be stable or can oscillate under any condition. Now we will see the stability circle on Smith chart. Here we can see the diagram of the Smith chart that isolated the stable and unstable region. The shaded region represents the stable region. For the stable, this tau output is less than 1 and tau in is also less than 1, as you can see in the figure. The method for the improving stability. We can improve the stability by adding the resistivity load. The transistor stability can be improved by adding small series or a large shunt resistor to the input or output. Resistor in a series or in shunt is decided after looking at the stability circle as we previously talked, the Smith chart. means stability circle of the circuit and input of the output stability circle. The addition of the resistor L or trade-off in noise and gain. Here we can see the resistivity load for the stability. Here we can add the resistivity in series as well as in parallel. The method for improving stability. Another method for improving stability is the feedback method. Feedback can be either negative or can be positive. Negative can be known as the degenerative, and positive is known as the regenerative. Negative feedback involves feeding a proportion of output signal back to input in a way that opposes the original input signal. Series feedback. Adding a feedback element, that is resistor or inductor, in a series with the input or output and thus improve the stability. While shunt feedback, adding the feedback element in parallel with the input or output. This can improve the input or output impedance matching. In this way we can improve the stability. Some benefit for feedback method is that it reduces the gain variation with frequency, improve the linearity and reduce the distortion, increase the bandwidth by stabilizing gain over a wider frequency range. And the next important aspect for designing MMIC amplifier is the noise consideration. We have to consider the noise as well. Johnson was the first to report the careful measurement of the noise in the resistor. Everything except the desired signal are known as the noise. The sensitivity of a communication system is limited by the noise. There are different types of the noise: thermal noise, short noise, flicker noise, and popcorn noise. This all noise should be considered for the MMIC amplifier designing. In the upcoming slide we will go detail for the thermal noise, short noise, and flicker noise, and as well as popcorn noise. Now, thermal noise. Thermal noise is a targeted charge carrier in a conductor constitute a randomly carrying current which gives rise to a random voltage. Thermal noise power is exactly proportional to the temperature. Here you can see the noise. Thermal noise is equal to K T del F, where K is the Boltzmann's constant, which approximate value is 1.38 into 10 to the power minus 23 joules per Kelvin. T is the absolute temperature in the Kelvin, and del F is the noise bandwidth in hours over which the measurement is carried out. Here you can see the thermal noise circuit diagram. Now the short noise. The fundamental basis for the short noise is the granular nature of the electronic charge. Two conditions must be satisfied for the short noise to be occur. There must be the first one is the direct current flow, and there also must be the proportional barrier over which the charge carrier can hook. And the second condition that tells us the ordinary linear resistor do not generate short noise despite the quantized nature of electronic charge. It is expected that the short noise current should be depend on the charge of the electron, the total DC current flow, and the bandwidth. So the short noise depend on the two. One is the current flow and other is the quantization nature of electronic charge. And now we will talk about the flicker noise. This is actually the mysterious types of noise. It can be also 1 upon f, that is frequency noise. This noise power decrease inversely with the frequency, means if the frequency is very low, the flicker noise is very high. Flicker noise is non-Gaussian and exhibit long-term correlation, unlike with the thermal noise. It is a long-term correlation. Flicker noise is observed in a wide range of device and material, including semiconductor device, resistor, and even in environmental system. Flicker noise can also rise in natural system like gravitation and the rotation of the earth, such as the fluctuation in the climate and the economic system. Now popcorn noise. Popcorn noise is also called the burst noise, beatable noise, and random telegraph signal. This noise was first observed in the point contact diode. Now both discrete and integrated circuit junction transistor have the popcorn noise. Unlike the continuous noise like thermal or flicker noise, popcorn noise consists of the discrete and the sudden changes in the signal. The amplitude of the jump can vary but is generally larger than other types of the noise. The occurrence of this jump is random and can vary over the time. Difference in manufacturing process and the material quality can lead to the varying these types of popcorn noise. Popcorn noise is vary according to the manufacturing process and company to company. Now, practical MMIC amplifier design. 3 practical MMIC amplifier design. In this slide, we will talk about the IF amplifier design, low noise amplifier design, and the power amplifier design. Here are the figure that the top figure is the layout of IF amplifier, and the right bottom is the fabricated KU band cassette amplifier design, and the right one is the fabricated power amplifier design. IF amplifier design. The IF amplifier boosts the signal to a reasonable input level for the set-top box. The primary function of IF amplifier is to amplify the intermediate frequency signal with the high gain while maintaining a linear response. The IF amplifier ensures that the signal is strong enough for the subsequent stages such as demodulation and detection. Two stages are used in the common emitter configuration for the broadband IF amplifier. Each stage has a resistor with an established contact DC current in emitter of heterogeneous bipolar transistor. Now we will talk about the cassette low noise amplifier design. This module was selected for the cassette stage because it has a larger emitter area for minimization of the base resistance. The base current was selected to minimize the power consumption and to obtain a low noise figure by keeping the device current density close to the minimum noise region of the operation. Here we can see the schematic diagram of the cassette low noise amplifier. Now, power amplifier design. The power amplifier ultimately can be considered from the energy perspective as a component converting DC power from the supplied DC into the microwave power. The power amplifier described as efficiency ratio between the output radio frequency and the supplied DC power. The power amplifier can be designed by using the same basic matching principle. Here you can see the energetic schematic representing of power amplifier operation. Now we will talk some of the importance in the modern RF and microwave technology. MMIC amplifier are integrated on a single chip, significantly reducing the size of the component. Modern RF and microwave technology, due to their compact size and high performance, reliability, cost effectiveness, and versatile ability to operate efficiently at high frequency, from 1 GHz to 100 GHz, make them indispensable in a wide range of applications, from telecommunication radar system to the medical device. This is the overall of the MMIC amplifier. Now, in this slide, we will talk some basic of the MMIC amplifier. Then we will go through the importance aspect of the designing MMIC amplifier, and also we talk about DC bias injection and classical stability and the gain analysis, in which we will talk the stability circle on Smith chart, method for improving stability, and the resistive loading and feedback method. In this slide we had talked about the noise consideration, in which we talk thermal noise as well as short noise, flicker noise, and popcorn noise. And also we had gone through the practical MMIC amplifier design, and in which we will talk about the IF amplifier design, low noise amplifier design, and at last we will talk the power amplifier design. Thank you.